Okay, so now here we're going to talk a little bit about soils of Costa Rica. The soils are without a doubt an important component of any country's natural capital. When properly used, soils should be a resource that we pass on to many generations, but oftentimes soils are misused and they can be eroded away, especially when we grow crops that leave the soil very exposed, right? Like when we grow what we call annual crops, corn, beans, soybeans, things like that. Because of Costa Rica's getting so much rainfall, and because a lot of the volcanic ash is rhyolitic ash, there's a pretty low percentage of Costa Rica actually has very good soils for doing farming. But one of the areas that had good soils for farming was this area where the Spaniards settled, that today everybody calls the Central Valley of Costa Rica, right? It started with Cartago, San Jose, Alajuela, Heredia. And why are the soils in this part of Costa Rica good for farming? Well, it's because of something we mentioned earlier, that a little to the northeast of where we are, in fact, if this was a clear day from where I'm standing right now, I could see the top of Irasu volcano. And over many millennia, Irasu and other volcanoes put out basaltic ash that came down here and, excuse me, anyway, the volcanic ash that landed here, that because we're in a cool climate here and we're almost a mile above sea level, the bacteria and funguses can't eat up all the organic matter. So this basaltic ash has combined with organic matter, and that has given us some very good soils here that are fertile and deep. When we talk about deep soil, we talk about the depth of this part of the soil that has more nutrients and organic matter, and that's called the A horizon. So what we're going to do today is look a little bit at the A horizon of this particular soil, which is pretty representative of the good soil that existed in this part of the Central Valley. The A horizon is different because unlike the B horizon, it has a loamy texture. It's not pure clay. And because it has organic matter, it has a darker color. It's not like light brown or, you know, beige colored or even slightly bluish like some clays are. It's a dark brown or almost black. So we're gonna, let's put in a tool that land use planners and agronomists use. It's called the soil auger, okay? Now there's no coincidence that this soil auger is 120 centimeters long, because if your soil is so deep that you're able to put the auger all the way in before you hit bedrock, that's a good sign. Or before you hit a water table, that's considered not to have, you don't have any limiting factors for the trees and plants to be able to grow their roots, okay? So what I do is this auger, to see how deep the A horizon is, we will basically take out soil, we'll put it on this sheet, and then we will put it on the sheet in the same order that it's taken out of the ground, okay? So what I'm going to go in, I'm going to take another, but look at that color. The first thing we see is the color looks pretty good. Okay, so now we can see how deep we've gone. Okay, so far we've gone about, wow, we've gone over a foot, and we're still, but judging by the color, we're still in the A horizon. Good sign. Continue on, keep getting out here. Okay, keep taking out more. And what I'm going to do today is I'm not going to go all the way to the, I'm not going to go all the way as deep as I can go to see how deep the A horizon is. Let me share with you that we have sampled in this area before. This is the patio of now a residential area here in the Curridabat neighborhood of San Jose. And we're seeing why this was some of the best agricultural land in Costa Rica. And during many, many decades, this was the very best coffee planting area of Costa Rica. Okay, so look, we've gone about 15 inches deep. And in the past, we've taken a sample of this, and believe it or not, we've gone all the way to the length of this auger, and we haven't even reached the B horizon. So that's an amazing sign. But again, this is due to many, many tens of thousands of years of fine basaltic ash deposit combining with organic matter that accumulated because it wasn't terribly hot. So the organic matter wasn't gobbled up right away by funguses and bacteria. That organic matter combined with this basaltic ash, and that together formed a very good soil for farming. But let's look at two aspects of this soil that are good. Okay. Okay. So here, basically, to look at the quality of soil, we put out what we've taken out of the ground on this sheet to better look at some of its qualities. Before we look at this, though, we should remember that only about 15% of all of Costa Rica's soil surface is really of good quality for agriculture. Okay. And a lot of things come into play that make a certain area good quality. So that's why the natural capital of good soil is so important to conserve, because it's not that abundant. You just can't grow crops anywhere you want. You know, people, especially crops that are very demanding. Why do we call crops like corn and soybeans and potatoes demanding? Because if you've ever been in a potato field or a bean field, a lot of the soil is exposed. It doesn't have a deep root system that can hold the soil. It doesn't have a really bushy crown that protects the soil from raindrops. So if you're on any kind of a severe slope and it rains, you can lose soil through erosion, okay? But what we're going to look at is two things here. We're going to look at color, because often color tells you how much organic matter is in this soil. And unfortunately, we don't have soil from a B horizon. If I had a lot of energy and a longer auger, I could go down into the B horizon, which is amazingly deep where I am right now. It's amazing that the A horizon is a meter thick here. You know, this was good farmland here. But if I had some B horizon next to this, you'd see the B horizon is like light brown or tan colored. But look how dark this is. Look at this almost black soil. This tells us it has a lot of organic matter. And even though we haven't measured the pH to see how acidic it is, remember, you don't want super acidic soils because they can hold more nutrients. I would say this soil does not have a pH like at 3.5 or 4. It's probably more like 5.5 or 6. And the organic matter plays a very important role, as manifested by the color and even pieces of roots and so forth. The organic matter plays a big role in keeping a lot of nutrients in this soil. So one of the things we look at is just look at the color. And then another thing that's very important for making soil valuable natural capital is its texture, because the texture plays a big role in our ability to produce especially demanding crops on it. What happens if we have a soil that's very sandy, has big coarse grains in it? Well, when it rains, it can't really hold water. It's like if you ever poured water through a pot full of sand. It just percolates very quickly through the water, and it takes your nutrients out of the system. And what happens if it's too clayey? If it's too clayey, often the plant can't put its finer roots in between the particles. A lot of times the clay solidifies and makes like a hard pan, so that water accumulates on top of it. It doesn't get oxygenated for good gas exchange and so forth. So what you want in a soil is an intermediate texture that's not super coarse and that's not super fine like a clay. So what we do here is we just hold the soil, rub it between our fingers, and I'm seeing that my first impression is that this has a pretty loamy texture. And what we do is, we always like to say that we bring water bottles, but if not, we use the spit test and we make the little snakes. Some agronomists actually put a little bit and they sort of chew it in their mouth along the teeth, and you can, because we're sort of looking at how gritty it is. Now I guess I should have a water bottle and be showing you this, but this is the old snake test that we do when we look at soils. If this was to be a whole very sandy, if this would be very sandy, this snake wouldn't bend at all. As soon as I started to just bend it, it would crack and break in half, right? But you can see I can bend it a pretty far away, but I get to this place and it starts to crack. See how it cracks? Okay, so if it had been if we would classify this as sandy, it would crack at the very start. And if it was pure clay, I could almost do a horseshoe shape and it wouldn't crack at all. But this cracks when it's halfway through. So that's another indication that this is medium textured soil, which is the best kind of texture that you can have for agriculture. Costa Rica is pretty different from other Central American countries in that it has a lot of volcanic ash deposited at more or less highish medium elevations. Like right now we're about 3/4 of a mile above sea level. So the evaporation rate is lower. And so we're seeing why the Spaniards decided to settle here. And of course, you know, what did they initially grow? They grew wheat, they grew corn, that they learned how to plant corn from the indigenous, other crops, cotton, things like that. But also we're seeing here one of the classic problems of urban sprawl. You know, this is land that ideally should be for farmland, but where the Spaniards settled, because it had good soil, their population grew, their cities grew, and they ended up having suburban areas over this soil. But yeah, this is a good example of good soil, a resource that definitely should be protected by some of the techniques that the agronomists teach us. They should be, we shouldn't be trying to grow plants on naked soil like potatoes and corn on areas that have a lot of slopes, with areas that get too much rainfall. We have to make sure we do contour planting. We have erosion control barriers of sticks and rocks. There's a lot of techniques we can use to try to conserve this really valuable capital.